Okay, raise your hand if you were not here on Friday. Okay, you will be completely lost. And we will laugh when you're lost, right? When we see that, Riley, when we see them crying, will we just point and laugh? Whoa, whoa, wow. That's your volleyball team the other day. Well, yeah, we did lose. Yeah, 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 yeah. Okay, all right. Good point. Okay, here we go. We got two problems today. We're talking about the area bounded beneath the curve. It says consider the area beneath 2x minus 1 half x squared from 0 to 4. And if you look at that function, what does it look like? What does that function look like? Parabola upside down, right? We want to find the area from 0 to 4. We want to do that. We don't want to draw two rectangles. We don't want to draw four. We want to find an infinite number of rectangles, the area of them, and add them up. So that's what we're going to do. We start out with this big idea. What's the width of the entire interval? 4. So what's going to be the width of each rectangle? 4 over n. Hey, there she is. Good to see you. For what x values do we evaluate the sum? Well, remember the big idea here, okay? We start at 0 and we go to 4, okay? So we would have to go over one width for the first rectangle, right? And one width would be 4 over n. Then we would go over another width, which would be 4 over n times 2, right? And you go over another, which would be width, which would be 4 over n times 3. So for what x values do we evaluate the sum? 4 over n times I. So that's where we evaluate the sums. So now we need to express this definite integral, then as a limit of Riemann's sum. The integral from 0 to 4 of 2x minus 1 half x squared dx. Don't forget the dx. Mark it wrong. Equals the limit. As n goes to, how many rectangles do we want? Infinite number. Times the sum from I equals 1 to n of f of x sub I. F of x sub I. Huh. What does that mean? What do I do? Plug in this guy where? Into the function. Now what's different here is we have multiple terms, don't we? So on Friday we started basic, just one term. Now we got two terms going on. But you look like a really intelligent group, so I'm not worried about you, except for those of you who weren't here Friday. So we're going to plug that in. So we've got 2 times 4 over n times I minus 1 half times 4 over n I quantity squared. We have to multiply that all by what? By 4 over n, because that's the width. You good? That's the key, folks. That's the setup. Knowing that this is 4 over n times I, knowing this is 4 over n, then plug him in the right spots. After that, it's just basic algebra. You guys are really good at algebra, aren't you? That's so great. So we want to multiply that expression out and factor it, leaving with only summations of I. It's going to take us a while to do that because there's a little bit of arithmetic going on here. We got the limit as n goes to infinity of 2 times 4 over n times I. What will this expression become? 8i over n, and I'm going to multiply it by 4 over n, and I get 32i over, good, sum from I equals 1 to n of 32i over n squared. Cool. Oh boy. Minus let's see, this will be 16 I squared over n squared times a half, 8i squared over n squared times 4 over n, 32i squared over n cubed. Can I show you some patterns to make sure that you guys know when you make a mistake or when you don't? Look at here. I have a linear term, x to the first power. So I is to the first power. I have a quadratic term, squared. So you see your I is squared. What do you notice about the n's? They're 1 degree higher. See that? Okay, that should happen every time. If it doesn't, something's going wrong. Okay, well, one thing we could do with summations is we can write them as two summations. So we could write this as the limit as n goes to infinity of the sum from I equals 1 to n of 32i over n squared minus the summation from I equals 1 to n of 32i squared over n cubed. You can just take the terms and break them into two summations. Now what I'm going to do is take the portion that is not the I, and I'm going to drop that out front here. Okay? It's just removing a multiplier. So now I have the limit as n goes to infinity of 32 over n squared times the sum from I equals 1 to n of I we gotta be careful. Like, there comes a time where we just start writing stuff down and we don't know what we're writing down. We're just like, oh, we'll just write down what's on the board. What comes next? Minus 32 over n cubed, sum from I equals 1 to n of I squared. Cool. That's awesome. Here's what I really, really like. I like this limit as n goes to infinity, and I have an n here. I want to get rid of the stupid I. What goes, just erase it. What goes in place of this? N times n plus 1 over 2. Good. What goes in place of this? Good. All right. So we got the limit as n goes to infinity, 32 over n squared times n plus 1 divided by 2 minus 32 over n cubed times n times 2n plus 1 times n plus 1 over 6. I'm looking for the enthusiasm. I'm getting kind of a, and I'm not too sure how today is from Kenzie. It's like, Gens, I want to like it, but not seeing the magic yet. Let's show you the magic. 32 over 2 will give me 16 over 1. And so I'm going to have the limit as n goes to infinity of, what's the top going to be? 16n squared plus 16n over n squared. minus, if you want to reduce 32 over 6, you can. I get 16 over 3. You don't have to. Sure. Do you want to do that? You want to get rid of an n right away? Okay. So what am I going to have here? 32n squared if you FOIL that out, if you FOIL 2n plus 1 times n plus 1, what do you get in the middle? 3n. So times 16. 48n plus 16. All over 3n squared. Well, hey, I know how to do those infinite limits. What do we factor out of the top? N squared. And what are you left with? D. Weiland is on a roll today. Minus, what do we factor out of the next one? N squared, and you get 32 plus 48 over n plus 16 over n squared, all over 3n squared. Now I'll put a smile on Kenzie's face. What happens? N squareds are gone, right? 16 over n is gone. N squareds are gone. 48 over n is gone. 16 over n squared is gone because you're letting the limit go to infinity, so those get super small, right? They go to 0. And you're left with 16 minus 32 over 3. Or 48 over 3 minus 32 over 3. Which is 16 over 3. Or if we're baking, 5 1/3. 5.3 repeating. I wonder if that's the exact area. Should we try that? Let's do it. Hey, don't go away. Huh? Oh yeah, we're right here. We're climbing, but we gotta be careful. Like we could just fall back down the other side, without a doubt. We could just run to the bottom right now. We don't want to do that. We want to work through the challenge. Point 0.5, yeah. X squared? No. 0.5x? What do I got? 2x? So I can calculate from? What? Jeez. Thought you were going to be nice to me. Lower limit 0, upper limit 4. Hope I get 5.3 repeating. Yeah, baby! Look at that! Oh, I like the way you think. First of all, if you go to 20, it's off of the chart, isn't it? So let's do 10. And this is this is great. D. Weiland, so proud of you because it's when you ask these type of questions that you really learn. Curiosity is the best way to learn. Go from 0 to 10. Watch what happens. Negative. See, calculus doesn't understand that area can't be negative. It says if you're above the curve, it's positive area. It says if you're below the curve, it's negative area. So integrals can have positive values and they can have negative values. Pretty sweet, huh? Take out your assignment. Here we go. Last example. Let's do it. We got 15 minutes. Think we'll run out of time? I hope not. Let's fly. Notice what's different about this one. 3 terms. What else? Doesn't start at 0. It starts at 2. What's the width of the interval? 3. So what's the width of n rectangles? 3 over n. It is not. When we start evaluating heights, we don't start at 0, do we? Where do we start? We start at 2, and we have to go over a width. What's our width? 3 over n times I. We go over 1 width, 2 widths, 3 widths, 4 widths from 2. So if you start at 2, then you got to do a 2 plus. So D. Weiland, you're right, 3I over n, but you got to do the 2 plus because you're starting at 2. We good? That's the only change. Now let's see how the algebra works out. See how good you really are. Express the area as a definite integral. The integral from 2 to 5 of 4 plus 2x minus 1 half x squared dx, don't forget the dx, equals the limit as n goes infinity of the sum from I equals 1 to n. What do I got to do now? Yeah, plug this guy into the function, right? Well, it doesn't matter for the 4, does it? Just got 4 plus 2 times minus 1 over 2 times 2 plus 3 over n I quantity squared. Is that it? Then you got times by 3 over n. So that's your width. Remember, how are we finding the area? We're taking the width times the sum of the heights, right? Well, this is just the sum of the heights. That's times the width. Don't forget to multiply by the width. Common mistake. Oh my goodness, we got to do that. Fortunately, you're really good at math. If you weren't, that would be a big problem. Okay. Looks like our notes are kind of, we're just going to write down a bunch of stuff. We're really not going to follow the organization here, are we? That ain't going to happen. Limit as n goes to infinity, the sum from I equals 1 to n. What do you want to do first? Should we just figure out the inside first and then multiply by the 3 over n? Because every year I do this, I'm afraid I'm going to get it wrong. Like it's easy to make a mistake on this. So let's try to be careful. I'm just going to go parentheses 4 plus 6I over n. I like the way you think. Minus, oh, I'm getting scared now. We're just going to do 1/2. I'll multiply that guy out. Oh boy, let's FOIL. What do we get? 4 plus 12I over n plus 2 times 3 is 6, and then you got to double that. 9I squared over n squared times 3 over n. I think we should take the 1/2 times all that stuff. I'm glad we're on the same page. I feel like we're pretty compatible, me and you guys. Four plus 6I over n. You could. Minus 2. Then what? Is it plus 6I or minus? Minus 6I over n. Nine I squared over 2 times 3 over n. N squared, thank you. Now I think we should combine some like terms, huh? When is n goes to infinity of the sum from I equals 1 to n. 8 minus 2, I got 6. Does that sound good? Hey, the 6 i's over n's go away, don't they? Yeah, I came up with 9i squared over 2. Hey, the 6i over n's. That's pretty fortunate, isn't it? Yeah. I feel pretty lucky about that. See, if you have a bad day later on, you got to think back to like something that went well. Just think back, oh yeah, the 6i's over n's canceled. It is a good day. Now I'm going to multiply by that 3 over n. I get the limit as n goes to infinity, which is just so fun to write. It's like, how does it go to infinity? It does. I equals 1 to n. 18 over n. Oh boy. Separate them. Like the way you think, Dulitz. Sum from I equals 1 to n of 18 over n minus the sum from I equals 1 to n of 27i squared over 2n cubed. I'm going to pause right now to just look. Is there something I can see here that tells me that I'm at least somewhat on the right track? Yeah, the I squared in the end of the third. So you have the second power and the third power. Here you have the 0 power and the first power, right? So that should always differ by a factor of 1. So good, good. So we got to factor stuff out that doesn't have an I, right? Now, I want to be clear here. In this case, you could take the 18 over n and put it out front. I'm just going to put the 1 over n out front. And I'm just going to do that to try to help teach you what this summation means. It's a very easy summation, but I'm afraid that you're not going to understand if I move the whole 18 over n out front. Okay, so we have the limit as n goes to infinity of 1 over n times the sum from I equals 1 to n of what's left? 18 minus 27 over 2n cubed. What's up, dog? Nice of you to join us today. You all okay? I'll show you in just a second, okay? Here's what this means, okay? It means I'm going to add up the number 18 n times. So do 18 plus 18 plus 18 plus 18 plus 18. Suppose I added up the number 18 10 times. What would you get? 180, right? This just turns out to 18 times whatever n is, doesn't it? Okay, so I left Katie and Gigi and Chris with this idea. We'll see if you guys remember. The sum from I equals 1 to n of I, do you remember what that came out to be, folks? We did this just the other day. You guys remember that? So we proved that summation last year in mathematical induction. Then we had the sum from I equals 1 to n of I squared was equal to. And then we did the sum from I equals 1 to n of I cubed was equal to n squared and plus 1 squared all over 4. So, but there's one that we left out, and that one sometimes doesn't get written down because it's kind of intuitive. And the idea is, suppose you have a constant here, and we said suppose you have 18. What do you get? Well, you get 18 times n. So in this situation, you get the constant times n. Okay? So let's go back to our piece, which sits right here. And Zach, see if this then connects for you, okay? I'm going to show you two ways. Number one, you get the limit as n goes to infinity. We haven't let that limit go to infinity yet. And so you have 1 over n, and this thing right here gets replaced by what? 18n. Now, suppose I would have changed it. Suppose we would have put the 18 out here. Then we would have just had 1 there, right? So then you would have had 18 here, and you would have just had n there, right? You still come up with 18n over n. I wanted to use the example of adding up 18 10 times. I thought that would help people understand what the heck's going on there. Okay. Minus 27 over 2n cubed times I squared. We've done that one many times. We know what that is. That's n times 2n plus 1 times n plus 1 all over 6. Okay with that? Okay, there I have it. I have the limit as n goes to infinity. We have 18n over n, which just simplifies to 18 minus, I think you guys, everybody has a different way of going through. You guys like to get rid of an n right away on this one, don't you? Okay, so we'll get rid of the n. This will be squared then. So I'll have 2n squared times 27 will be 54n squared. Then in the middle, you get that 3n. And 3n times 27, you guys all know is 81n, right? Good job. And then at the end here, you're going to have just 27. And that's all over what? Looks like I got a 12n squared. So I have the limit as n goes to infinity of 18 minus, what do you factor out of the top? N squared. Up to 54 minus 81 over n. Well, plus 81 over n plus 27 over n squared. All over 12n squared. What happens? Let the limit go to infinity. The 81 over n is gone. The 27 over n squared is gone. The n squared over n squared is gone. 18 minus 54 over 12. Let's see. Both are divisible by 6, aren't they? It'll be 9 over 2. So 36 over 2 minus 9 over 2. I got 27 halves. You may use a decimal, but I expect to see some of these numbers come up in the meantime because you can just press second calculate on your calculator, right? So sometimes people just put that decimal. Make sure that all your work supports your answer. I will give you those formulas. Good work, everybody.